So next architecture difference is that is the fifth difference is the connection to the other networks. How the connection is made in case of a wired network, and how connection is made in case of a wireless network. So that we are going to see, right? So in wired LAN, the networks are interconnected via routers or bridges, right? So in case of, I have already discussed, right? So in case of wired LAN, two different LANs are connected using a router to build the larger networks, right? So in either you can use routers or bridges, right? In case of wired LAN, all the communication between networks happen through the routers, right? So whenever a particular LAN, let us assume this is a LAN which has 5 devices or 5 laptops or any host you can say, and this LAN, second LAN, uh, which has 10 hosts, right? So and these two are connected with the help of a switch, right? And to this switch a router is connected, right? So this is the architecture of a wired LAN, right? So bigger LANs can be used, bigger LANs, if you want to create a bigger LANs, that can be created with the help of a centralized switch, right? So to which two LANs are smaller LANs are connected, and this switch is in turn connected to a router, because router is required, because if you want to, if we are connecting, if we are connecting two LANs in the same building, let us assume in our college mechanical department has one LAN and ENC has one LAN, right? So these two LANs are going to be connected to a central device called a switch, right? So now if I want to connect a LAN which is present in our college and the LAN which is present in another college, like let us say GIT, right? So if I want to connect one LAN present at JCE, one LAN present at GIT, then in such cases those LANs are going to be connected with the help of a router, right? So because a router is going to carry the information, or whenever the information is sent out of JCE, that has to pass through a router which is going to connect two different LANs, right? So let us say this is a JCE campus and this is a GIT campus. So both LANs are going to be connected. In this case, this switch will not come into picture, right? So whenever you are connecting two different LANs which are present in the same building, then we are going to use a switch, right? So if you are connecting two different LANs which lie in two different colleges, then we need a centralized router, right? So every information which passes through from one college to another college, that has to pass through the router, because we are going to build a larger network. I cannot call here including two college networks as LAN, right? A simple LAN. I cannot call the two college network as a LAN, right? So the one college network is a LAN, another college network is a LAN, right? So I am connecting two LANs to create a bigger LAN. I can call that LAN as my MAN also, right? Metropolitan area network as well, right? So here the data has to pass through the centralized router, right? So this is the case in case of wired LAN, right? So all the communication between networks happen through the routers, right? If they are connected if two LANs of same buildings are connected, then routers will not come into picture. Only switches will help you to move the data from one building to another building in the same college campus. So but when the picture is of two LANs which are present in two different colleges, then we require routers. Third one, the IP addresses will be used for this communication, because the routers is coming into picture. Router, we know that the router falls in network layer, and the network layer will add IP addresses. Router will always see the IP addresses for the communication, right? The physical addresses are not changed. Small mistake here, changes I had wrote. make it changed, not changed until the NIC is changed, until the network interface card of that particular device which are installed inside that particular device is changed. Until and unless that NIC is changed, the physical address of that particular device will not be changed. And even IP addresses are going to remain same until the host does not move from one network to another network, right? So IP address is also going to remain same, because until and unless the device are present in JCE, until and unless the device are present in GIT, the IP addresses are not going to change, right? And if I move one system, if I move one system from GIT to JCE, then the IP address of the moved system will be going to change, right? So that we have seen already in case of mobile IP, right? So whenever the user moves from one network to another network, his home IP address is going to change, right? So this is the case in case of wired LAN, right? So moving to the wireless LAN, in wireless LAN, the hosts are connected to the central device called the access point in the network, right? So this I have already discussed, right? So all hosts are connected to a centralized device which we call it as access point. So I have highlighted this in red because these are very important. Note that the role of the access point is completely different from the role of link layer switch in the wired environment, right? So I have already told this, that the reason will be cleared when the role of switch and the access points will be discussed, right? So the role of access point is completely different than the role of the switch in case of wired environment. An access point is gluing two different environments together, one wired and one wireless, because I told you, right? So this access point is connected to a backbone system with the help of a wired LAN, right? And to form a simpler LAN, right? So these all systems are going to be connected to this access point with the help of a wireless, right? So the dashed line is a wireless LAN, and the solid line is called a wired LAN, right? So here the operation of access point is completely different than a switch, because switch in case of wired LAN connects the different devices or the different switch with the help of a wired or physical channel, but access point is going to glue two different types of LANs. One at the backbone end it will be a wired LAN, and at the system or the LAN end it is a wireless LAN, right? A wireless LAN, right? So this is the main difference between access point and the switch, and this is the main reason why access point is not called as a switch. So an access point is gluing two different environments together. One is wired, one is wireless, right? So because of this reason, in case of wireless network, the centralized device is not called as switch, right? Next one, the communication between the access point and the wireless host occurs in a wireless environment, as I've already discussed, and the communication between access point and the infrastructure occurs in wired environment. Here the infrastructure refers to the backbone system, right? So moving to the next slide, I've included one diagram there, so you can observe in this diagram. It includes both the wired LAN as well as the wireless LAN, right? So in the wired LAN you can say this is one LAN which is connected to a centralized device that is called a switch, and this switch is in turn connected to one more device which we call it as a router, and this router is connected to rest of the wired internet, right? So but in case of wireless network, you can see access point is going to be connected to these laptops using a wireless, right? So and this backbone system, this is the backbone system, right? So this backbone system is again making use of a wired LAN. It will make use of a physical channel to connect that access point to a router and router to the rest of the internet. Clear? I think the point, the difference between the switch and the access point is clear to you, right? So moving to the next slide, this is the last difference, you can say. This is the last difference between the wired LAN and the wireless LAN. Moving between the environments, when the hosts move from one network to another network, then what happens, that we are going to see, right? In wired LAN or a wireless LAN operates only in the lower two layers of a TCP/IP protocol suite. What are the two lower layers of a TCP protocol suite? One is a physical layer, one is the data link layer, right? The physical layer I have already discussed. The physical layer is going to convert one form of the signal into another form of the signal, and this physical layer is going to give services to a data link layer, right? And this physical layer is also going to connect the frame to the underlying network, right, by converting one form of the signal into another form, right? And the data link layer, it will encapsulate the packet coming from the network layer. It will add the physical address of the destination and the source physical address, right? Then it will encapsulate, and it will also include the trailer includes the CRC to check the error or to detect an error which is going to happen during the communication, right? So in wired as well as wireless LAN operates only in the two layers of TCP/IP until and unless they are working with the access point or a switch, right? So when the router comes into picture, then one more layer is going to be added to this, right? So in that case, the definition may going to change. It works with the lower three layers of TCP/IP, because router falls in this network layer, right? So router falls in this network layer because router has three different layers. One is physical layer, data link layer, as well as the network layer, right? Next, this means that if we have a wired LAN in a building that is connected via a router or a modem to the internet, all we need in order to move from a wired environment to the wireless environment is to change the network interface cards designed for wired environments to the ones designed for wireless environments, and replace the link layer switch with an access point. Yes, right? So when we want to move from wired LAN to wireless LAN, then the address is going to change because the network interface card for wired LAN is different and the network interface card for wireless LAN is different, right? So since the NIC network interface card is going to change, obviously the physical address of those particular device is going to change. So whenever the physical or whenever the network interface card is going to be changed, we are going to get a different physical address to those devices. So if we want to move from the LAN to wireless LAN, what we need to change the network interface card, which are made up of which are made for the wireless environment, and we need to change the switch. In case of wired LAN, the connecting devices are called switch or routers, right? We are going to replace them by the access points, right? So even wireless routers are different and wired routers are different because the algorithm or the software which are installed in those routers will be different. For wireless, the protocols will be used as different protocols are used, like Bluetooth, Wi-Fi, Zigbee, right? So these are the different protocols which are used in a wireless technology. And in case of wired technology, we have already seen Ethernet protocol and all that wired protocol we have already seen, right? So again, you have to when we migrate from wired LAN to wireless LAN, so these all changes are going to happen. switches are going to be replaced with access points, NIC card needs to be changed, and the wired routers are going to be replaced with wireless routers. And the last point, we are moving from wired links to wireless links, right? So we are moving from wired links to wireless links. For that, these all changes are made before the actual migration is going to be happen, right? So these are the different architectural comparisons between the wired and the wireless LAN. So in the next class we will discuss the general topics of wireless LAN. Okay, thank you.